How do you prevent overfitting in regression algorithms? Imagine you're trying to teach a friend how to recognize different types of trees. If you show them only a few specific trees, they might memorize those exact trees instead of learning what makes a tree a tree. That's similar to what happens when a regression model overfits. It learns the training data too well, including noise and random quirks, and then struggles to predict new data accurately. To avoid this, we need smart strategies that help the model focus on the real patterns. One effective way is to use cross-validation. Think of it as testing your model on different groups of data to see if it performs well across all of them. You split your data into several parts, train on some, and test on others. This process helps you find the right balance so your model isn't just memorizing the data but learning general trends. Regularization is another key method. It adds a penalty to the model's complexity, discouraging it from fitting every little detail. There are two common types: L1 regularization, which can shrink some coefficients to zero, effectively removing unimportant features, and L2 regularization, which keeps large coefficients in check. Both methods help keep the model simple and prevent it from overreacting to noise. Adding more data is also very helpful. When you give the model more examples, it learns broader patterns instead of memorizing specific points. This makes it better at predicting new data. If you only have a small data set, the model might latch onto irrelevant details, but with more data, it's less likely to do that. Reducing the number of features can also help. If you have many variables, some might be irrelevant or redundant. Techniques like principal component analysis can combine features into fewer, more meaningful ones, making the model less prone to overfitting. Simplifying the model itself is another good step. For example, choosing a linear regression model instead of a high-degree polynomial regression can prevent the model from fitting noise. Using a less complex model helps it focus on the main patterns without getting distracted. Early stopping is a practical approach during training. You monitor how well the model performs on a validation set and stop training before it starts to memorize the training data too closely. This way, you prevent overfitting from happening. Finally, it's important to avoid target leakage. This means making sure your features do not contain information that wouldn't be available at the time of prediction. If the model has access to future information, it will perform and realistically well on training data but fail on new data. In the world of artificial intelligence and machine learning, including tools like ChatGPT, DALL-E, and Midjourney, preventing overfitting is vital. It ensures that models learn the true underlying patterns and not just memorize examples. This leads to more reliable and fair outputs, especially when models are used in real-world applications. When models overfit, they can produce biased or misleading results, so applying these techniques helps build trustworthy systems. Overall, stopping overfitting in regression is about balancing the complexity of your model, the quality and amount of data, and how you validate your results. This way, your models can make accurate predictions on new data and serve their purpose effectively.